Least common multiple is your next lesson here. Let's go ahead and get started here. We have a few vocab terms that we need to go over. One of which is multiples. What is a multiple? The product of a number and another whole number. Maybe the worst definition of all time in mathematics, because it really is kind of hard to understand what that really all means. But what is a multiple? A multiple is a number that when you multiply by a whole number, you get another whole number. But not only is that whole number a product of that number, it's also divisible by the number you originally started with. So that is confusing too. It's hard to explain this, but it's a really simple thing. Let me just show you. You know, a multiple of 9, for instance. 9 times 7. 63 is a multiple of 9. A multiple of 12 could be anything. There's an infinite number of multiples of 12. 12 times 11 is 132. The fourth multiple of 15 is 60. 15 times 4. So as you can see, these are multiples right here. 63 is a multiple of 9. It's also a multiple of 7. 132 is a multiple of 132. And it's also a multiple of 11. 11 times 12. Same thing with 60. A common multiple is a multiple that is shared by two or more numbers. That's going to be the focus of our lesson today. Common multiples and least common multiples. Least common multiple is the smallest common multiple among or between two numbers or more than two numbers. So here are some multiples of 8. There's the first multiple of 8, 8 times 1, 8 times 2, 8 times 3, so on, 8 times 5, 8 times 6, 8 times 7, and for infinity. Multiples go on forever and ever and ever. If someone says, hey, write all the multiples of 8, you couldn't do that. It would be impossible. You would have to do that forever and ever and ever. Multiples of 3, same thing. Start with our first multiple of 3, which is 3 times 1. 3, 6, 9, 12, 15, 18, 21, forever. They just keep going and going. As long as you keep going up by 3, you're doing multiples of 3. But they go on forever. Okay, here's our first example here. Example 1, find the first 3 common multiples of 6 and 9. So the first 3 common multiples of 6 and 9. So in order to do that, we're going to need to find the multiples of 6 and 9. So let's just make a list. And the biggest question I always get is, how many multiples should I make? And the best answer to that is a lot. You know, try to make as many as you can. Just don't write 2 or 3. Sometimes you have to write several. So just write small, write as many as you can, be thorough, and you should be able to find enough multiples of 6 and 9. I'm going to jot down some multiples of 6. There's 6 and 12 and 18, 24, 30, 36, 42, 48, 54, etc. Now that's not a ton, but that should do the job. Here are some multiples of 9. And now let's compare. So if you look, the numbers that are highlighted in green are the multiples that they share. So what does that mean? Those are the numbers that they have in common. They have 18 in common, 6 and 9 share 36, and 6 and 9 share 54. There are more numbers that they share, you know, way on down the line, but we're just looking for the first 3. So 18 is a multiple of 6 and 9. 18 is 6 times 3, and 18 is 9 times 2. So that's a multiple of 9. 36 is a multiple of 6 and 9. 6 times 6 is 36. And 9 times 4 is 36. 54 is a multiple of 6 and 9. 54 is 9 times 6. And 54 is 6 times 9. There you go. So what are the common multiples? 18, 36, and 54. Those are the first 3. And then this leads into, you guessed it, least common multiple. Now looking at that list, all you have to do is just point out the one number that's the smallest. 18 is the LCM right there. That's our LCM. That's our least common multiple. That's the smallest number that is common to both 6 and 9, and it's a multiple of 6 and 9. 18 is a multiple of 6, and 18 is a multiple of 9. Here is your next example. Find the LCM of 3 and 4. Now this is not too difficult. Let's go ahead and use the listing method. list out the multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, and on and on and on. I'm going to list off several multiples of 4, 4, 8, 12, 16, 20, 24, etc., etc. So find the LCM of 3 and 4. So now let's start looking here and compare what they have in common. There they are. They have 12 and 12 right here. There's a 24 and 24 right here. And there's going to be more. If I were to make this list longer, same thing down here. If I were to make those sets longer, then there would be no end to the number of multiples that they have in common. What we're looking for, though, is the LCM, and that's 12. Okay, here's your last example. This is an application problem that involves LCM. A Target employee is stacking 8-inch and 10-inch boxes into separate stacks. One stack has the 8-inch boxes and another stack has just the 10-inch boxes. How tall will the stacks become until they are both exactly the same height? So this is an LCM question. Let's go ahead and list the multiples of 8. If you have one box, it's going to be 8 inches tall. If you have two boxes, it'll be 16 inches tall, 8 times 2. 3 boxes will be 24 inches tall. 4 boxes will be 32. 5 boxes will be 40 inches tall. 6 boxes will be 48. 7 boxes will be 56 inches tall. And 8 boxes will be 64 inches tall. And 9 boxes will be 72 inches tall. So I ran out of room, so I stopped there. If you had to go on, keep going. Don't just stop there. Sometimes you have to keep going. You have to be persistent. Now I'm going to go ahead and list some of the multiples of 10. Now multiples of 10, those are going to be the boxes that are in the 10-inch box pile. So one box is going to be 10 inches tall. One box is 10 inches. 2 boxes will be double that, 20. 3 boxes will be 30 inches tall, 40 inches tall, 50, 60, 70, 80, forever and ever. Now we're trying to answer the question, how tall will the stacks become when they are both exactly the same height? How tall? So we're looking for a multiple that they both have in common. And there it is, 40. So the stacks will be 40 inches tall. Now here is a literal picture of this. The blue box is 8 inches tall. The red box is 10 inches tall. So as you can see from the picture, the 2 of each, they're not the same. 3 blue does not equal 2 red. 3 red does not equal 3 blue. 4 blue does not equal 3 red. And obviously it's not the same. And there you go. They're both exactly the same height. I know it's kind of hard to tell from this picture, but these numbers are exactly the same height. So what you can do is just compare the two piles. Okay, now it may be difficult to tell here, but they're both exactly the same height. The 8-inch pile has 5 boxes, 1, 2, 3, 4, and 5. The 10-inch box pile has 4 boxes, 1, 2, 3, 4. Because 5 times 8, that is a product of 40. 10 times 4 is also 40. So we got the same height. That was the deal. That was the exercise. We wanted to have the boxes to be the same height. That does it for this flip lesson. Make sure you guys take good notes, write down examples. You shouldn't just have numbers with no descriptions in your flip notes. You shouldn't just have numbers scattered all around the page with no descriptions or no words. You should have steps written down. You should have vocabulary written down. You should have examples written down. So make sure you're taking good flip notes, write a little summary, and I'll see you the next time. Take care.